This thing sucks. Literally. It uses a DC fan and a carbon filter to pull smoke away from my face. Precisely. The smoke you see while soldering, it's not harmless. It's rosin flux burning off, releasing particles like colophony that can irritate your airways and contribute to long-term respiratory issues, even occupational asthma. So, keeping that colophony out of your lungs is probably a good idea. I've been soldering for almost a decade now, and honestly, I've never used any kind of ventilation.
Now, how many levels are there?
Just one.
Oh, really?
Yeah.
One day, while I was working on another project, my mom mentioned,
Hey! Whew, it stinks in here. You should get some kind of ventilation. Just an idea.
and instead of doing the normal logical thing, like wearing a mask, I decided to design, 3D print, and build my own fume extractor. I started sketching out some rough ideas for what it could look like. At one point, I even considered using HEPA filters from my desk vacuum. But before locking in any sort of design, I did what any normal person would do. I watched some YouTube videos. Some builds had ducting systems, some were battery powered, and even a few were made out of wood. And honestly, looking at other people's designs can be very inspiring, and you can take bits of pieces of different ideas and make it your own. But it can also be very demotivating because it's like, wow, these people are incredibly creative, and like, how could I ever build something as cool as them? But that mentality is a trap. So what do? We get to work. Version 1.0, the first prototype. The first version was simple. A tiny 50 by 50 millimeter brushless fan, activated charcoal filters, a barrel connector, a toggle switch, with a hexagon pattern grid, all packed into a small 3D printed enclosure. The electronics housing slid in nicely, but the issues showed up very quickly. I used an old LED light base, but it was too top heavy. Airflow was very poor. The walls were too thin, the screw hole interfered with the barrel connector, and the top cover was very ugly. Version 1.1. Small fixes, but the same problem. I kept the same fan, but swapped for a better switch, one that actually worked. Added a 3D printed hood for better fume collection, and even poured concrete into the LED light stand base. The spacing with the electronics was much better, but the airflow still wasn't cutting it. It was tedious to assemble, the screws still poked out of the top. Even with the concrete, the stand still was not sturdy enough, probably because I poured the concrete poorly. Version 2.0, the big upgrade. I upgraded to a 120 by 120 millimeter 12 volt DC fan, designed a much larger housing, 4 screws to attach the hood, and even a funnel adapter to connect everything from the air duct, and designed a swivel joint for adjusting and positioning, and mounted it on a repurposed microphone stand. It looked pretty cool, but the new issues popped up. The top plate leaked air. I didn't like the speed control on the power supply. The filter didn't slide all the way in. The swivel joint sagged over time, and the airflow was just not good. The funnel adapter was actually choking the whole system. Oh, and the enclosure wasted a ton of filament. I thought it would have been a good idea to make it one solid piece. Turned out to be a waste of filament because the filter didn't fit properly. I just didn't like the way it was. I wasn't satisfied. I was not satisfied yet, so.
Oh my god, bro.
So we keep going. It's the only solution. I mean, trying something else. That's all there is to it. I design something, I print something, I assemble it, and I'm like, oh crap, this is bad. So then I find out what's bad, I change the bad on CAD, I print it out feeling rad. Oh. Sorry. Anyways, version 2.1, fixing the root problems. I slimmed the body down just a little bit to reduce the amount of filament. I moved the mounting plate to the bottom, and I added a nice cable gland for the barrel connector instead of just having an open hole like the previous version. And I rebuilt the swivel mount so it actually held its position instead of falling over time. I split the whole system into 4 components, similar to what I had in the original. The main frame, the bottom cover, the grid, and the hood. I also upgraded to a stronger power supply that I took from an LED light strip. I cut 4 LED strips, mounted them to a little frame, and soldered them together into a square ring light around the hood. Not only does this look cool, but it actually makes soldering a lot easier because this thing is so large, it actually covers a lot of my light from my desk light. So including LEDs inside of the fume extractor itself just makes sense. Another thing, I designed a clamp that lets the extractor to attach a gooseneck helping hand. I think that's what they're called, gooseneck helping hands. These kind of like little foldy thingies. You know, yeah, like the bendy hose, similar to another project I have with a bendy hose. This little helping hand gives a lot more adjustability for soldering parts, and when I need more fingers, I have little clampers, little fingers. So, this is pretty much it in all its glory. This project has been going on for a while now, since I've also have a full-time job and make music. Yeah, it's been, kind of just tackling it one day at a time. I hope you like it. This is pretty fun to build, and I hope I can maybe inspire you to come up with some of yourself or take ideas from other people and modify it in your own way, kind of like what I did. Thanks for watching. See you in the next one. Peace. By the way, if you want to make this yourself, all the links are in the description below, with the STL files to the fan, the stand, and everything else I used.